Hi, in this video we are going to go over the solution of the problem 21st, merge two sorted lists. For example, I have a list L1 that is 1, 2, 4, and I have a list L2, 1, 3, 4, and I want to merge these two lists to one giant list that is sorted. Something like this one. For doing that, we are going to use linked lists. First, we need to define what is a node in Python. The input to that is data, the value of the node, and by default the next is none. So for the first list here, I have node 1, 2, 4. The value are defined, and also I define how these nodes are connected to each other. So for example, node A is connected to node B to node C. And then I define similar things for the second list. So this is for the second list. As a result, I have these two things. So I have the first list here and the second list here. So I'm gonna call the first head by L1 and second head by L2, and the function that we have called merge two lists. So it gets two heads and it's going to return to us the merge list, linked list. Okay. Let's start solving this problem. The first thing that I'm going to do is that I'm going to define an extra node and I call it prehead. And I give the value -1. It doesn't matter the number, just the number for the value. And then I'm going to use the value variable prev and prehead. Okay, so that's going to be here. And then I'm going to start going forward in a while loop and say while L1 and L2. While we have both of them and none of them is none, we go forward in this while loop. And what we do is that we do a comparison. We say if L1 value or data is less equals than L2 dot data, in that case I refer my prev next to L1. Okay. Else I refer that to L2. If this one is smaller, so I go here because we want that be sorted. So we want at the end these numbers be 1, 2, 3, 4 increasing. So because of that, whatever is smaller, so we refer to that one. So I refer to this one if this one is smaller. If this one is smaller, I refer to this. If it's equal, it doesn't matter, but I refer to the L1. But whatever we refer to, then we move that pointer 1 ahead. So now L1 comes here. So I have to say L1 equals L1 dot next. Okay, because L1 dot next was node B. Now I make that one the L1. And similar things for the other case. L2 dot next. Okay, that is good for our if statements. We are still inside the while loop no matter what condition we have. Every time we are going to move forward for the prev. So it's prev dot next. Okay, and there might be a condition that for example here we visit 1, 2, 1, 1, 2, 3, and then 4, and then this is going to none. One of them is not is none, and it's gonna be a stop. Actually, this should be and. But we still the other one is not none. So in that case, we are going to attach the remaining of the second list to that to the list that we just created. We are going to say prev dot next equals L1 if L1 is not none. Because for example, L1 came here, is not none, but L2 is already none. So I'm just gonna say okay, just attach this to the end of that. Else L2. Okay, So we have these things, and the only thing is that we just need to return the value, return prehead dot next. Do you remember prehead here? So we had the prehead as a node here, this location, and now the next to that is the beginning of the head of the new linked list. Okay, so if we do that, now let's run that. So I'm going to run and print in a nice format. So I'm just printing the first list, the second list, and run the function, and then print in a nice format. Okay. Okay, this is the result. And if you look at the time complexity, so the time complexity is order of n plus m, where n stands for the length of the first list and m for the length of the second list. Because we just moved over list once, each list once, so this is going to be n for this one and m for the second one. And the space complexity is the order of 1, because we are not creating any array or list or anything to store the data. We are just having some comparisons. Okay, this is the solution to the problem 21st. Thank you so much for watching this video.